Welcome to today's chemistry lecture. In this lecture, we are going to study our next topic, which is change in mass during a chemical reaction with the formation of a gas during a chemical reaction. So, without wasting time, let's start our today's lecture with step by step and point by point concept of this topic. So, change in mass during a chemical reaction says that the law of conservation of mass as the total mass during a chemical reaction always remains exactly the same. This strict requirement is dictated by the law of conservation of mass, which is always obeyed. Second, apparent mass change. Despite this law, some reactions appear to change in mass during the process. This usually happens when a reactant or product is a gas. In open container and closed container, we will see how they will react differently. First of all, let's see in an open container. If the containers are open, if a reaction is conducted in an open container where gas can freely escape or enter. If a gas is evolved, escapes, we observe an apparent decrease in mass. If a gas is absorbed, enters, we observe an apparent increase in mass. If the containers are closed, if the exact same reaction are performed in a closed container, no mass can escape or enter, and the total mass remains the perfectly identical before and after the reaction. For example, if a gas is evolved, we shall observe a decrease in mass, and if a gas is absorbed, the parent mass will be increased. For explaining this example, we will see the experiment. If a ribbon of magnesium is burned in an open crucible, the mass of the product formed will be greater than the reactant. This increase in mass has occurred due to the reaction of magnesium with oxygen in present air. However, if the two reactants are allowed to react in a closed container, the total mass will remain the same before and after the reaction. Let's see the formation of a gas during a chemical reaction. If a reaction is performed between the marble chips and dilute hydraulic acid in an open container, the mass of product will be less than that of reactant. It will decrease the mass due to evolution of carbon dioxide gas during the reaction, which escapes into the atmosphere. Further, if the concentration of the reactant decreases until the reactant are used up, at the same time, concentration of product increases and reach maximum value at the end of reaction. Let's see the figure 17.2 that about the concentration time graph. So, as the chemical reactions move forward continuously through the time, first fact, reactant decrease. The concentration of reactant starts at its maximum and steadily decreases until the reactant are completely used up. Second, products increase. Simultaneously, the concentration of the product starts at zero and steadily increases, reaching its maximum value at the very end of the reaction. So, this was the art today lecture. Hopefully, you will understand it step by step and point by point.